Hello everyone, welcome back to a second video of our geology session. So in this video we are going to begin with the next three chapters, that is petrology, structural geology and economic minerals and rocks. Okay, so let's move on. Let's see what we can do from these chapters. Okay, so here is let's start with the chapter petrology. So from this chapter we are going to study all about rocks. Basically the main chapter of rocks starts from this. So let's begin. Okay, so I'll give you some important underlinings as I've given you in the first video. So let's see. Petrology is a branch of geology which deals with the study of rocks. Then the term petrology is derived from the Greek word petros, meaning rocks, and logos, meaning study. Everyone knows this as usual. So come down over here. This is another thing: petrography, description and systematic classification of rocks. Petrogenous, study of origin. Okay, so rock is an aggregate of minerals. Whatever I'm underlining, that you have to remember, as I've told you in the previous video. Same thing. Okay, most of it have two or more minerals. Example granite. However, few are of single mineral. Example dunite. Some rocks are have fossils, and so they are called as fossiliferous limestone because fossils are plants and animals. Some may be formed in the recrystallization of pre-existing rock. Example marble. So let's start with the main. First, we are going. This petrology is divided into igneous, sedimentary, and metamorphic petrology. So let's start with the first part. Igneous petrology. Okay, so the first formed rock on the earth are igneous and primary rocks. Okay, the term igneous is derived from the Latin word igneus, meaning fire, through which cooling and solidification of magma or lava. Okay, so these rocks may be formed with or without crystallization, either below the surface as intrusive. So below the surface is called as intrusive rocks, okay, which are called as plutonic rocks, and on the surface is called as extrusive rocks, called as volcanic rocks. So remember this, important. Okay, next come to the next part, next side. Okay, then what are primary minerals? Are minerals which are developed as a result of crystallization of magma or lava. And secondary minerals are those formed after the solidification of the rock, that is either by alteration of the primary minerals or by precipitation. Okay, now inside primary minerals there are two groups. That is essential and accessory. So essential minerals are what? Here essential minerals are necessary for identification, classification, nomenclature. Okay, accessory minerals are present in small amounts. Okay, so they may be present in the rock, not be present also in the rock, therefore they are not important in nomenclature. Okay, so example I've given: granite and quartz, feldspar are essential minerals, while biotite and hornblende are accessory minerals. Okay, this is in granite. In granite, quartz and feldspar are essential, biotite and hornblende are accessory. And okay, so presence of accessory does not make any difference. Okay, either it's present or no, but essential minerals should be present. Okay, now there's another thing of secondary minerals given us. Secondary minerals are those which are formed due to secondary solutions in cavities of igneous rocks or volcanic rock. Example calcite and zeolite. So whenever there are some holes present in the rock, secondary minerals take their position. Okay, now these secondary minerals can be felsic or mafic. Now what is felsic and mafic? Felsic are light color minerals. Okay, what I'm underlining, you have to remember that because this can be asked, okay, in your college exams also, with low specific gravity. Example minerals from silica and feldspar group. Okay, next is mafic minerals. Mafic minerals are what? Dark minerals. They are dark in color, okay, with high specific gravity. So the difference between this, okay, example is pyroxene, amphibole, mica, olivine. So examples of both are given along with their description, so you have to remember that. Next is rocks can be described as pheneric or phanerocrystalline. Okay. Now what is pheneric? See, pheneric or phenerocrystalline, if the minerals can be present with naked eye, if you can see the minerals with naked eye, they are called as pheneric. Okay. Now if you can't see the minerals with naked eye, then they are called as coarse grain. Okay. Coarse grain. Coarse grain is granite. Okay. Okay, sorry. Naked eye. Okay. Pheneric and coarse grain are the same. Okay. And ephenitic rocks which you cannot see. Example is rhyolite, which you cannot see with your naked eye, is rhyolite. Okay. So we move on to the next page. Classification of igneous rocks. Classification of igneous rocks. Okay. So igneous rocks are classified. Igneous rocks are formed at great depth inside the earth. Inside the earth means below is called as plutonic, as I told you. Okay. This is from where it is derived. Okay. An example of plutonic is granite. Okay. Okay. Then rocks which are formed above the earth's surface is called as volcanic rocks. Okay. Example of volcanic is basalt. Okay, basalt. Then there is hyperbasalt rocks also, which consolidate at the depth in between volcanic and volcanic pluton. So in the middle, hyperbasalt comes in middle of volcanic and plutonic. Example is dolerite. Okay, they have an intermediate position. Second is based on silica percentage. Based on silica percentage, okay, acidic with silica percent greater than 65%. So greater than 65%, it is acidic. And that best example is granite. Intermediate, in this range if it comes, then it is this is the example of intermediate. Cyanide. Basic, in this range 45 to 55, basalt. And ultra basic, less than 45% is peridot. Okay, for now to remember all this, there is a nice table given on the next page over here. Okay, you can see over here acidic, intermediate, basic and ultra basic, and these are the rocks which come under that: plutonic, hyperbasic, volcanic. Okay, so you can learn this table. Okay, this is the mineral content. Color index we have not come, I'll tell you that later. Okay, next, rocks based on color index. So felsic, which are light colored minerals, as I told you before, light colored minerals are called as leucocratic. Okay, and leucocratic are acidic rocks. Okay, so you can compare from that table and you can come to know. Example is granite. Same thing, this granite. Intermediate igneous rocks have color between acidic and basic. They are called as mesocratic. So intermediate between acidic and basic is called as mesocratic. Example, cyanide. Next, rocks which are mafic minerals, dark colored minerals. Dark colored minerals are called as melanocratic. Okay, and they are basic rocks. Basic rocks. Okay, example, augite, hornblende, olivine. And ultra basic are very dark, darker than melanocratic also. They are called as hypermelanocratic. Very dark. Example, peridot. Okay, so remember this 4 classification based on color index. And you can see over here it is come in this also, color index. Okay, the rocks are classified over here also. So you can learn this entire table and that's it. You're done with the classification of igneous rocks. Okay, next we move on to the structures. Okay, so we move on to the structures now. Textures, sorry, not structures. Yes, move on to the textures, not structures. Structure is the next part. Textures first. So textures, what is textures? First of all, textures is a mutual relationship of minerals or glass contained in the rock. Example, relative amount of crystalline glassy matter as well as size, shape, arrangement of minerals. Okay, now this part, equigranular texture, this had come in 2022. This is 2022 ka question. It had come for 2 marks. Okay, yes. So what you have to remember this entire paragraph to write the thing for 2 marks. If the rock consists of mineral grains of almost equal size, okay, they are called as equigranular structure. A best example is granite. You have to write this paragraph for 2 marks. Okay. No, the question was what are igneous textures and explain equigranular texture. So if this is for 1 mark and this is for 1 mark, so equal to 2 marks. Okay. Next is equigranular structure. In equigranular structure, nothing. Just the basic difference is they have different size. Okay, they have different size. That is why called as inequigranular. Example: porphyritic texture. Okay, that's it. Porphyritic texture in basalt, I think. Yeah, the rocks like as basalt. Okay, as I told you, you have to remember this table. This table is important. Okay, table is important. Okay, it comes from here sometimes to identify the rock, like whether silica percentage greater than 65, identify the rock. So granite, which comes in the plutonic below, so they can ask granite. So that way they can ask any question based on this table. Okay, next we move on to structures of igneous rocks. Okay, structures of igneous. First structure is vesicular structure. Vesicular structure is what magma erupts from the surface to form lava. When lava is rich in gases and volatiles, erupts and gases escape into the atmosphere, leaving cavities behind. This is the main, leaving cavities behind. Okay, when the cavities are present, then only vesicular structures form. Now these cavities are called as vesicles, resulting in structure called as vesicular structure. Okay, example is vesicular basalt, and this is another one actually. Okay, vesicular basalt. Okay, they are pipe shaped. Okay, they are pipe shaped. So what I have underlined, remember this, they are cavities formed due to when lava erupts, okay, out in the form of lava erupts and gases escape from the rock. So there are cavities left behind called as vesicles, and those vesicles are fulfilled by these sort of rocks. Okay, example is vesicular basalt, amic dialoidal basalt. Okay, vesicles can subsequently get filled by secondary minerals such as calcite, zeolite and varieties of silica. So those vesicles can be fulfilled by these three: calcite, zeolite and silica. Such filled vesicles are called as amic dales. This is an important, amic dales. Okay, then it is said to be as amic dialoidal structure. Okay, this is you can see these cavities over here. This white is only actually what? Calcite, zeolite. Okay, these are the vesicles. Next is ropey structure. Ropey structure is due to low viscosity and which flow at greater distances. What is that? Lava. Okay, lava flows at low viscosity and greater distances. During the process, upper surface gets wrinkled, resembling ropes. Upper surface gets wrinkled. Okay, matlab that gets merged, like called as ropey structure. Columnar structure forms columns. That's it. Due to rapid cooling of basic lava, cooling structures develop. Lava tries to aggregate around the center due to the result of contraction. Due to this tensile strength is developed due to the strength at right angles. Columnar structures. You can see the figure in the next thing. Okay, the figure is not given here. It's given in the next chapter, I think so. It's not given. At right angles, such vertical joint cracks. Such joints result in the formation of hexagonal, polygonal, columnar, rising columnar structure, columnar basalt. Example is columnar basalt. They have given the picture in the next. Okay, so the main description is this only. Rapid cooling, lava tries to aggregate, results of contraction during cooling, and also tensile strength is developed, which results in right angling of the rock, forming hexagonal columnar structure. Pillow structure usually doesn't come, but I'll tell you. Hot lava erupts under the water. Okay, you can just tagging over pillows get stacked above one another, forming pillow structure. Okay, pillow shows glassy structure. That's nothing much. Okay, now there is another one, types of igneous bodies. Two types of igneous bodies: extrusive and intrusive. So extrusive, nothing much. Extrusive, that's lava flows, that's it. Okay, lava flows only from extrusive igneous body. Okay, this is nothing much actually. Deccan Plateau Basin example of lava flow. Okay, intrusive is important. Intrusive may, the form of intrusive bodies depends upon viscosity of magma and structure. In igneous intrusive bodies are classified into concordant and discordant. Yes, this is important. This can come as distinguish also or compare also. Concordant bodies are more or less parallel. This is an important. Parallel to the structure of the host rocks, and discordant bodies cut across the host rocks. Okay, once again I'll repeat. Concordant bodies are more or less parallel to the host rocks, while discordant cut across the host rocks. You will come to know in the figure now. Okay, now concordant also are divided into different types. The first one is sill. What is sill? Sill means shelf or a slab of stone. It is a tabulous sheet of igneous rock between parallel of existing strata. Okay, so concordant is what? They are more or less parallel. So let us say sill is parallel to the host rock. Yes, you can see over here sill. See, sill is over here. Is it parallel? Yes, it is parallel to the host rock. See, sill is parallel over here. Okay, it's parallel, right, to this black line. Look at this black line and look at this sill. This sill is a red one. So they are parallel. Okay, they are thin tabular sheets of magma. Okay, so okay, parallel upper and lower. Let's give you the underlinings. You have to just learn, remember that. Okay, they may a few meters to 100. Their thickness is this much. On the basis of origin, sills are differentiated into simple, multiple and composite. 3 types of sills. Okay, simple, multiple and composite. Simple sill is formed from single intrusion, multiple from 2 or more, and composite from more than 1 rock type. Okay, next we come to is laccolith. What is laccolith? Laccolith means Greek word lakos meaning cistern and litho meaning stone. Okay, it is a bun shaped structure. This is important. Bun shaped structure having a flat base. Okay, it is like something like this. Bun shaped structure having a flat base. See over here, the base is flat. Okay, and dome top. Yes, you can see over here dome top, and not spread very far. Tends to heap around it heaps itself up around the orifice of the eruption. The strata above it is generally inverted, like a inverted bowl. This is important. Inverted bowl. Few in kilometers the diameter, 1000 in meters thick. Okay, so you want to, this had come in 2022. Okay, so this had come in 2022. Laccolith for how many marks? For 3 marks this had come. Okay, so this 3 marks with the diagram. So what diagram you have to do? You see, where is laccolith? Yes, this is laccolith. You can see over here laccolith. So see, are they cutting across? No, see, they are parallel. Okay, they are parallel. This is laccolith. Okay, so it come for 3 marks. So you have to truly draw this diagram, this sort of diagram resembling with the host rock, and this description. 2 marks for description and 1 mark is for diagram. Okay, this had come in 2022. Okay, so next we move on to lopolith, the third type. Okay, so what are these? These are ulta. Laccolith and lopolith just ulta there. Okay, they are sunken saucers, centrally a sunken saucer of basin-like concordant bodies called as lopoliths. Okay, lopos means basin. Matlab they are just reverse of it. Ulta. Okay, ulta there. Okay, their thickness is 1/10 to 120 of its width, and diameter ranges from 10 to hundreds of kilometers. The characteristic shape is resulting a sagging caused due to the weight of the intruding magma. Matlab in this part there is lot of weight, that is why this sags down like a inverted basin. Okay, like a basin. There is lot of magma here, that is why it becomes ulta. Okay, so any one of this can come. So write the description and order the diagram for 3 marks. Okay, so last time this had come 2022. Next we move on to phacolith. Okay, you want to show a lopolith in the diagram is given over here. Lopolith. Okay, see, this is saucer shaped lopolith. Okay, see, they are parallel to the host rocks. Next is phacolith. Phacolith meaning lens. These are crescent shaped structures which represent highly folded mountains. They are formed from crest and troughs. Okay, crest and troughs you may be learning in physics also. Up down you may be learning in the practical examination. Tuning fork may will learn this crest and trough. Okay, region of weakness tension exhibit double convex lens like form. Okay, any one point also they can ask. So like example, it's like that. Okay, crest and trough. This is crest trough. Okay, and so on it goes. Okay, so where it is in the diagram? Yes, see, phacolith. Crest and trough. Yes, see, crest and trough. Okay. Next we move on to discordant. There are only two types of discordant: dike and sill. So dike means what? Now dike is discordant, means they are cut across. Cutting relationship they have. They cut across. As you can see over here, they cut across. See, they are cutting across the black lines. These black lines are cutting across. Okay. So I'll just underline the video. I can't explain everything. I'll just underline the important things. Okay, you can read out this. That's it. It's more than enough. Okay. Okay, I have underlined my books. I'm just seeing from my book and underlining. Vertical, these all are the key features. Okay, you can underline in your book too. Okay. Next is batholith. Batholith is also, you can see batholith is the largest of all. You can see over here down, batholith is the largest of all. So what are these actually? They are extremely large dimensions, large scale intrusions, steep dipping walls. They are granitic in composition. Stock and boss are offshoots of batholithia. This is important. Where stock is irregular and boss is circular, less circular, both are less than 100 square meter aerial dimension. What I am underlining is important. Xenolith are fragments of conductor found in batholiths. Okay, they are pendant shaped body. This was another one. Okay, next we move on to the next part of the chapter, sedimentary rocks. Okay, so this is the formation of sedimentary rocks. You can, I'll mark it as a paragraph. Next we move on to sedimentary rocks are formed. Okay, so they can ask a question: how are sedimentary rocks formed? So you have to you can't learn all this. Okay, so there are 5 points basically. So whatever you can write in your own words also, but you should know the technique of writing. Okay, first step: weathering, erosion, transportation, deposition, lithification, and cementation. Okay, mostly this doesn't come in board exam. Maybe they might ask in your college exam. So you can just read it off. Classification of sedimentary rocks. Sedimentary rocks are classified. This table is important. Okay, maybe they don't ask usually, but even though I'll mark it as important, it can come. Okay, now the next part, that only classify sedimentary rocks, transported and non-transported. Okay, so non-transported rocks are, this had come in 2022. What had come? Only the give example of non-transported rocks 2022 for 1 mark or 2 marks, I don't remember. So the example of non-transported rocks are laterite and bauxite. So this had come in 2022. Only the examples that asked. Okay, only the examples. Okay, so you can read this. They are known as sedentary deposits. Okay, this is laterite and bauxite. Okay, transported rocks. Okay, now transported rocks are divided into clastic and non-clastic. Yes. So clastic rocks are rudaceous, then there is arenaceous, then there is argillaceous. Okay, argillaceous has 2 types. Okay, so what is rudasias? Rudasias are rudites. Okay, they are grey in shape. You can see this with your naked eye. Okay, they mainly consist of boulders, cobbles, pebbles. Okay, they are formed, transported by traction. This is important. Transported by traction. Okay, and this was the question which had come in 2022 also for 3 marks. 2022 for 3 marks. Okay, transported by traction. This full paragraph you have to learn. Example is conglomerate. Okay, arenaceous, they are sand size grains. They are transported by saltation or suspension. What I'm saying important, what I'm underlining double time, you have to remember that very nicely. Okay, arenaceous are coming 2023, I guess. Okay, their size is this. Example is siliceous sandstone and ferro. Okay, so arenaceous consists of sandstones only. Okay, next is argillaceous. Argillaceous is argillite, short form. First one is siltstone. They are finer than sand. You can't see with your naked eye at all. Can't see at all. You require a microscope. Okay, they are transported by suspension. Okay, shale is made up of clay particles, transported by suspension. Example, clay stone, mudstone, shale. This is the size. Shales normally exhibit lamination. Okay, next, second part is non-clastic. Okay, these are the table given. How was the stones given, like acidic, basic. This is same rudaceous, arenaceous, argillaceous. So even if you learn these 3 paragraphs, is more than important. Of this one, rudites. Okay, rudites, arenites and argillites. It's more than important. There's no need to do this. Okay, non-clastic is, I'll tell you what is important is, you come to the next page. Come down. Yes, organic deposits is important. Chemical deposits not that important. Organic deposits is calcareous, phosphatic, ferruginous. They asked, you know what, they asked the examples basically of this. In my college exam they had asked the example, and carbonaceous. That is, I am marking this. Okay, next is textures of sedimentary. Classic texture, sedimentary texture. Okay, so tell you what is important. Yes, stratification. Different stratification comes. Yes, it comes. It came in 2023 ka exam, I think so. Bedding, planar bedding, cross bedding. Okay, you can read this off. Okay, you can read this off and you can see what you can underline of yourself, what you feel important. Graded bedding. This table is important. This table comes usually, I had marked it important for me at least. Cross bedding, ripple marks. Okay, these all are types. Okay, just read it off. Next is metamorphic metrology. I'll give you the underlinings. Metamorphism, this is important. Come down. Yes, agents of metamorphism, this is important, very important. It had not come, but it can come in your college exam. Okay, this is the types of metamorphism. Cataclastic, thermal or contact, dynamothermal. Cataclastic may pressure plays an important role. Okay, pressure plays an important role. Okay, so you have to just remember this. Okay, like answers, they are like big answers, short notes. Okay, so you can read this off. Thermal may who plays an important role? Temperature plays an important temperature. Okay, pressure is negligible over here. See, pressure is negligible in thermal because thermal or heat, so temperature. These are formed due to granular structure. Limestone form marble, sandstone form quartzite. Okay, dynamothermal. Okay, both involves in this, both high temperature and high pressure. Dynamothermal. Okay, complete recrystallization is done. Here what partial recrystallization will be done, I think so. Recrystallization is given anything. Okay, so you can see over here I marked everything what is important. Okay, thermal contact metamorphism में pressure plays an important role, and cataclastic में thermal में temperature plays an important role, and cataclastic में pressure plays an important role. Okay, this conversion, you have to remember this conversion also. Okay, dynamothermal में both complete recrystallization is done, and foliation is a typical characteristic of this. Intensity of the dynamothermal increases with depth. Okay, hence argillaceous rocks, shales are altered, like shales are altered to phyllites, which further increase in temperature. Schists are developed. Okay, first argillaceous are converted to phyllites are then converted to schist. Okay, structures of metamorphic rocks. First one is slaty cleavage, directed pressure. Due to pressure this happened. Okay, this comes under cataclastic metamorphism. Example. Okay, next is they're generally rich in micaceous mineral. Mica is present on these rocks. Okay, granular structure that develop due to thermal metamorphism. Okay, which undergo recrystallization due to directed pressure. Limestone and sandstone simply recrystallize to marble and quartzite. Okay, so this is thermal ka. Next is cystostructure. This had come in 2022 का exam में. 2022 for 2 marks. Okay, this structure is marked by linear or parallel arrangement, direction perpendicular to the maximum stress. So basically this maximum stress matlab it is what? Thermal metamorphism. It is cataclastic only. Okay, because stress is there, na, pressure. The cystostructures developed due to undirectional alignment such as biotite, muscovite, chlorite and tile, flaky mineral, hornblende, columnar rod-like experience. Okay, this is okay. High temperatures and pressures. Okay, you can see this flaky foliation due to cystostructure. Gneissos. This structure is present in the rock due to the flaky mineral quartzite. Flaky mineral quartzite give rise to cystostructure. Okay. Now, how is this gneiss structure formed? When granulose and cystose bands alternate each other, gneiss structure is formed. Okay, black, white. You can see over here. High temperature and direct pressure pre-accretion rock. Okay, so basically this is dynamothermal comes under. Next, we move on to next part is building stones. This is also another question which had come in 2022. Okay, 2022 a question. This is for 2 marks. Okay, crushing strength. Okay, these are the all characteristic feature. Okay, so you have to learn at least, there are how many points given? There are 8 points given. At least 5 you have to remember. As per mine, I had studied the first one, studied the third one, I had studied the 5th and 7th one. 5th, 7th and 8th. Okay, so I studied at least 5. So you read it, you will automatically understand. Okay, now we move on to the exercise part. An example of discordant igneous intrusion is batholith. Next is hyperpacial equivalent of basalt is dolerite. I have already given you the underlining. You can refer the underlining and you can see how I am marking the answers. Okay. The sedimentary rock in which constituent grains are rounded, conglomerate. One of the structures exhibited by sedimentary rock is cross bedding. Okay. The thermal metamorphism of sandstone in the formation of sandstone results in the formation of what? Quartzite. Foliation in rock is a characteristic feature resulting from dynamothermal. Example of concordant bodies are concordant, sill, lacu and lopu. The wavy pattern seen is what? Called as ripple marks, right? Okay. So this is I told you to refer that table. That table is very important. Yes, they asked in the match the following also. So its correct answer is C. Residual rock chemical. This is again the this. What is that? Argillaceous chemical deposit, organic deposit, residual rock. Okay, so this is correct answer will be D, I think. D. This is the structure of apna last metamorphica. You can refer that and do. Answer is B. Okay, so what is a rock? I told you in the starting only. What is one meant by the textures of rocks? Next is name the texture of igneous rocks which exhibit a large variation in grain size and shapes. Name the texture of igneous rocks. Equigranular and inequigranular. Give 2 examples of evaporites. You can write it in your book, okay? Evaporites is calcite and gypsum. What is stratification? As I told you, underlined. Okay. What is graded bedding and what is meant by metamorphism of rocks? All similar questions, okay? You can identify it reading the chapter as I told you. So that's it for this chapter. Let's move on to the next chapter. Okay, so our next chapter we continue with is structural geology. This I feel is the most important chapter. Okay, so let's begin structural geology. Okay, so I directly go with the main part. Okay, so come down, stress and strain. So you can see stress is the pressure applied. This will not be asked. It's like this is a what is stress. Okay, so there are 2 types of stress, lithostatic and directional stress. Lithostatic is when stress is applied in all different directions, okay, because of different weight. Okay, lithostatic and directional stress is only in one direction, okay, due to the tectonic motion, the tectonic extension. Okay, they are differentiated into tensional, compression and shearing stress. Okay, tensional is what away, compression is towards, and shearing is maybe in different direction but in this it towards the center. Okay, strain is a deformation. Okay, types of deformation, this is important. Okay, from here the basically the chapter starts, like the main part. Okay, main part is from here. Okay, types of deformation: elastic, plastic, brittle and ductile. Okay, from this the most important elastic only. Why? Because over here they have mentioned a law, Hooke's law. Okay, so this had come in 2022 for 1 marker. See from where they remove these questions. It had come like, which law describes, okay, yeah, that which law describes that the rock deforms like a spring? So many of them had got wrong. So the answer is Hooke's law. Okay, plastic deformation, you can read it. Okay, I don't feel anything much is given. Directly we come on to this graph also is not important, but you can see this as compared to plastic. Elastic is with respect to stress and strain. Elastic goes in a straight line. When plastic comes, it turns, and this is the fracture caused due to brittle. No, I don't feel brittle, not brittle. Okay, but it's brittle and ductile deformation. Okay, this is, I don't feel anything important. This is the main part, measuring the attitude of beds. The simplest form of deformation exhibited in any region is tilting. Okay, this is okay. Let's go forward. I don't want to read anything. Yes, the position of the bed on the ground surface expressed as attitude. Important. What is attitude? Attitude of the bed can be quantified by strike and dip. Important. Okay, whatever I'm saying important, marking double times, you have to learn that very thoroughly. Okay, next part, which is very important. This every exam they ask, every exam, 22, 23, college exams, everything they have asked. The most common tool to measure strike and dip of an inclined bed is the compass, or Brunton compass or clinometer compass. Yes, this. Okay, measuring strike and dip, Brunton compass or clinometer compass. Now what is strike and dip? From when we are saying strike and dip, before learning strike and dip, we learn what is an outcrop. So an outcrop, any geological formation exposed on the surface is called as outcrop. Okay, this also can come as define. Okay, so what is strike and dip? Basically, strike and dip refer to the orientation or attitude of geological feature. Orientation, basically where it is oriented as per the geological strata of the particular bed. Okay, so let's see, there it's given the definition. Okay, it says that strike refers to the directional of a horizontal line on any plane, inclined bed, fault plane or a planar structure. Okay, continue. The strike direction is the direction of the line of intersection of that feature with the horizontal plane. What is strike and what is strike direction? This paragraph. Okay, important. Next is dip. What is dip? Dip literally means slope or inclination. Dip is expressed both as direction and amount of angle. Okay, this is all. Okay, this is about dip. And what is dip direction? Strike direction, dip direction. Okay, and this is dip. What it means slope. Okay, and this is dip direction is what? Direction on maximum inclination of the bedding plane occurs. It is measured in the direction which is 90 degree to strike direction, which is called as true dip. So what I have marked is important. This is what I have marked is important. Okay, everything is important. Okay, now the amount of dip or angle of the dip gives the steepest angle and uska range होता है 0 to 90, not exceeding 0 to 90. Okay, not less, not more. Okay, this is about the Brunton compass given. So let's move on next. This is the Brunton compass if you want to know. Okay, next we move on to what is apparent dip. Okay, so the dip angle and the in this chapter lot of definition and small points to remember, small things. Okay, that is why I told you it is an important chapter. What is apparent dip? True dip is always greater than apparent dip. Okay, next the apparent dip is the inclined bed. Okay, this is not important. Let's come down. Okay, here one thing is important is that being 0 parallel direction is equal to true dip direction perpendicular to strike. Okay, so true dip is in direction is perpendicular to the strike. Okay, this table is with respect to strike and dip direction. Okay, I forgot to tell you about this diagram. Yes, I had to explain this diagram also. See over here, this is the dip direction. Dip direction will always be perpendicular to strike. Okay, dip direction will always be perpendicular to strike. See, dip direction is here, strike is over here, so they are perpendicular. So see, they are perpendicular. This is strike angle, this is dip angle. Strike angle with respect to this planar structure, and dip with respect to this planar structure. Okay, these are the sedimentary layers, this is the exposed rock. Okay, and this is the two layers which separates the two geological strata of the particular bed. Okay, this is the that's basically that only. 0 to 90, as I told you, it lies only in that range, horizontal, vertical, incline. Okay, so it's important if you want to remember. Next is fold. Okay, fold, I'll mark it here. This is the definition of fold. You can read it out. Compressive forces, they bend upward, downward, hence result in fold. Okay, compressional forces. Okay, so this is the fold. Compression forces, up and down, crest and trough results in fold. Elements of fold: axial plane, axis or hinges, crest, trough, limbs or flanks. Okay, axial plane. Yes, this is the axial plane. Axis, and this is the axial plane over here. Next, this is the fold. No, where is this? Hinge lines. This is your hinge line, left, right. These are your limbs: left limb, right limb, left limb, right limb. Okay, next is what? Crest and trough. This is your crest, this is your trough, crest, trough. Okay, this is okay, so you can read it off. You can, this is little bit, you can relate physics with this, not much. Types of folds, important. Types of fold is anticline, syncline, symmetrical and asymmetrical. Okay, symmetrical are two types, symmetrical anti and syncline, and asymmetrical is anticline, syncline. Okay, so anticline is convex upwards. Anticline is convex upwards. See, anticline is somewhat like this, anticline. Okay, so you can anticline. Okay, so convex upwards. Okay, the limbs are anticline, dip away from each other with reference to axial plane. Okay, syncline, they are opposite of anticline, but they are this direction, somewhat this way. Okay, opposite of anticline. The limbs dip towards each other with respect to axial plane. They are convex downwards. Okay, they are towards the core or center of the curvature. Symmetrical folds, you can read it off. Symmetrical, anticline, syncline, this is important. Same thing it is actually. Basically the two limbs dip away from each other in anticline. Syncline may dip towards each other at the same angle, but in anticline at away from each other by the same angle. Okay, only this is a difference. They dip away in anticline, dip towards in syncline. Asymmetrical, almost similar. This had come in 2022. Okay, asymmetrical fold had come in 2022 for 3 marks. For 3 marks, how? Explain this for 1 mark, explain this for 1 mark, explain this for 1 mark. So 3 marks total. Okay, okay. Again, in anticline they dip away from each other. You see, syncline may they dip towards each other, but in asymmetrical they are different by different angles. This is the major difference between asymmetrical and symmetrical. Okay, next we move on to significance of folds. Okay, nothing much comes from this. Okay, you can see this mountains are for mountain building, groundwater source, oil gases, and nothing much from here. Next we move on to faults. Fault is a planar structure in a volume of rock which has been significant displacement along the fracture as a result of earth movements. Okay, this is the definition of fault. Okay, so this had come again in 2022 for 3 marks. Okay, for 3 marks, this entire paragraph for 3 marks. Okay, 2022. Next we move parts of the elements of fault. How there was parts of fault, that were parts of fault. Same thing like fault plane, footwall, hanging wall, heave and throw. Okay, oh sorry, this is the sorry, footwall and hanging wall. Okay, so these are the two parts. Fault plane is what? This is the fault plane. You can see this is the fault plane, this FFF, which divides these two structures. This is one structure, this is one structure, divides into 2 parts, so it is fault plane. You can see why this FFF, so it's divided into 2 planes. This is a strike S and this is a dip. They are always perpendicular to each other. Footwall and hanging wall. Footwall is what? Lies below the incline, the faulted block which lies below the fault plane is called as footwall. Footwall, and which rests above the fault plane is called as hanging wall. So this hanging wall is always hanging. Okay, this will be fault plane. This is footwall, this is hanging wall. Fault trace. Okay. Next we move on to measurement of movement of slip. Okay, the displacement that occurs through the faulting is called as slip. Net displacement, total slip is net slip. Heave and throw. What is heave and throw? Horizontal component of displacement is heave, vertical component is throw. Okay, horizontal is heave, vertical is throw. Diagram. Anything they ask, give the explanation along with the diagram, because diagram is for 1 mark basically. Okay, if there is a diagram in the textbook. Types of faults. Normal fault. There are lots. There are many faults. There are 5 faults. Okay, so types of fault. First is normal fault. Basically just hanging wall with respect to footwall. That's it. Hanging wall is displaced down with reference to footwall. You see, hanging wall is down with respect to footwall. Okay, so Normal faults have dip greater than 45 degrees. Strong tensional forces. Next is reverse fault. Reverse fault is what? Just ulta. Hanging wall moves upwards with respect to that, and dips are greater than 45. Yeah, what? Yeah, ulta it was. This is just reverse of that. Okay, there's a strong compressional forces, tensional, compressional. Okay. Next is thrust fault. Thrust fault is what? Low dip, angle less than 45 degrees. Special case of, it is a special case of what? Reverse fault. मतलब ये this is reverse fault का उल्टा, thrust fault. Strike slip fault. Strike slip fault मतलब what? The blocks slide past each other. आगे पीछे let it be. Okay. They are also called as lateral fault, trans fault, or wrench fault, or tear fault. So many types of names. They can also ask the names. Okay. Basically, what is lateral fault? So you will say lateral fault. There is no lateral fault only. I have learned strike slip. So they are the same. Okay. Step fault. Step fault is what? Set of parallel normal fault given a regular step-like appearance. Step-like appearance called as step fault. You see, up, down, down, down. See, down, 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 and so on. Step-like fault. Step-like appearance. Horst and Graben is what? When normal fault with mutually diverging or converging fault planes occur with a few wedge-shaped block called as Horst and displaced upwards. The Horst is always on top. Graben is always on down. Horst, Graben, like crest, trough, Horst, Graben. Graben. Okay, so Graben is downwards. Okay. Horst Graben of large magnitude result in formation of block mountains and rift valleys. Yeah, valleys are formed because see, if a Horst is present over here, so this will be a mountain. Down will be Graben, so this will be a valley. So you can see mountain valley. Significance of faults. I'll tell you this. Learn the first three, 1, 2 and 3. Okay, learn, then you come to this, learn this one and 7th one. Okay, just read it, and even if you know 2 is more than enough actually. Next is joints. Joints are what? All types. Joints are fractures found in all types of rocks. The presence of the joint divides the rocks into a number of part or blocks through segments. Okay, this is okay, nothing much. Yes, types of joints. Last year this had come 2022. Okay, so 2022 2 joints had come. Strike joint and dip joint both had come. For 3 marks. Both had come for 2022. They had asked to simultaneously together what are strike and dip joints. So along with the diagram, okay, you have to joint parallel to the strike is adjacent. Joint is parallel to the strike of adjacent bed. Okay, you can see over here MNO. You can see this thing MNO. This is parallel to what? Is parallel to strike? Yes, it is parallel. Dip joint. Joint is parallel to dip. Let's see whether it's parallel to dip. Yes, see MNO. Yes, it is parallel to dip. So that's it. This is the main key word you have to remember. Diagonal joint. They are also called as oblique joints. Okay, they are oblique to the strike and dip. Matlab they are neither parallel, they are neither perpendicular. Matlab at one point, oblique matlab what? At one point they will meet. You can see your strike is going forward, they will meet. Your dip is going forward, they will meet. Okay. Bedding joint. Bedding joint is what? The whole bed is considered parallel to the bedding plane. MNOP. Okay. You can see over here A, B, C, D is gone underneath actually. A, B, C, D. Okay. Columnar joint. Columnar structure you had even seen over there in the petrology. So I'll show you over here columnar joint. Yes, this is a diagram given. See, hexagonal, polygonal structure. See, formed into igneous. Same thing, same explanation actually is given over here also. Yes, igneous rocks, cooling of lava, same thing. Okay. So if you remember the description of that, you can write it over here. But respect to joints, okay, this is. Don't write with respect to rock. Okay, they are parallel, straight. I'll underline this thing. Okay. basalts. Okay, basalt, which is an igneous rock, right? They're found in this, okay, this part of India. Significance of joints is over here. Nothing, you can just read it off. I don't feel anything important. Okay, next part we move on to is, okay, so I've marked everything over here with respect to joints and the significance of joints. Nothing much important of significance. You can, okay, so these are the types of joints. Next we move on to unconformities. Unconformity ka definition is directly given over here. Okay, this entire thing, this is an important, I don't know what word is given over here. Wait, I'll read this off. Geological time not represented is called as hiatus. Okay, hiatus not represent geological time. Types of unconformities. Angular unconformity. Angular unconformity is what? When the younger beds and the older set on the strata are not mutually parallel. Younger bed and older set of strata are not mutually parallel. They are called as angular unconformity. You can see over here. Younger beds and older set. These younger beds and this older set, they're parallel. No, they're going to meet. They're over like that, and one is like that. So they're meeting, right? So they are angular base. So this you can see over here, there is an angle formed. There is an angle formed over here. So they are angular unconformity. Example, Hutton's angular conformity at Sikar. Disconformity is what? Are usually erosional contacts that separate parallel bedding planes from the upper and lower rock units. These are mainly formed in sedimentary rocks. Okay, they are parallel, but the older and younger are parallel. Okay, this is the unconformity formed. Okay, disconformity between sedimentary and California is the example I have given. Okay, non-conformity, when the underlying older formation is represented by igneous or metamorphic rocks, the unconformity is called as non-conformity. Okay, a non-conformity suggests that the period of long uplift weather erosion. Okay, so the main part is, yes, this is the main part. Okay, this full thing till non-conformity you have to learn. Okay, with the diagram. Okay, so remember the diagram. Basically what it says that when underlying older formation is represented by igneous rocks, मतलब older formation is igneous rocks or metamorphic, but the overlying मतलब ऊपर का is younger formation made up of sedimentary rocks. That is non-conformity. Okay. Significance of unconformities. Just learn this one thing. Okay, nothing. Okay. Next we move on to yes, the direction of a line formed due to intersection of exercise. Okay, due to intersection of an inclined bed with horizontal plane is called as strike. An imaginary plane that divides the fold into two equal halves is called as axial plane. An anticline is a fold that is convex upwards and oldest bed at its core, at the core. In asymmetrical syncline, the two limbs dip towards each other by different angles. A fracture which there has been no slipping or displacement is called as a joint. The type of wall in which hanging wall, block wall has been displayed upwards with respect to footwall is called as reverse fault. An unconformity in which the older bed is made of igneous or metamorphic rock is non-conformity. Match the following. Okay, this is all the types. Okay, so you can refer that, and the correct answer should be 2. Next, second ka correct answer should be 3, all about folds. And third ka correct answer should be all about conformities. It is You can read the description, you will come to know on your own. Okay, yeah, okay, nothing much. You can read this off all as I have underlined everything. You get everything is in the textbook itself. Okay, okay, so that's it for this chapter. Let's move on to the next chapter. Okay, so let's move on to a last chapter for this video, economic minerals and rocks. So as I told you, I will be providing you with a paper of 22 and 23 ka PDF. So maybe it will come in this video. I will put it in this video basically. Okay, so this chapter is like very big. Okay, like too much big it is, like all about minerals and rocks at a country level. Okay, so I will not waste much time. Okay, because you have to, this is basically chapter mostly is used in practicals. Okay, your teacher will explain everything for you in practicals. Okay, so let's start. Basically, what is economic geology? Okay, the branch of geology that deals with economic minerals. I only give you the underlining. Okay, I'm not explaining much of this because it's like understandable. Okay, so I'm just giving you the underlining so that you don't miss out anything, and also the 2022 ka kuch questions. Okay, so this had come in 2022. What is an ore? What is ore? For 2 marks it had come. Okay, so you can't write only this first line. Okay, natural concentration of one or more minerals, that is rock from which one or more minerals can be extracted economically. You can't write only this for 2 marks. It will write something more. Ore are important metals such as you can as aluminium, iron, this example. Okay, ore comprises of ore minerals, gangue minerals and country rock. You can also say this. Okay, so this 3 underlining can be set for 2 marks. Okay, next is come to the next part is gangue or gangue. What do you say? Gangue is called actually. Gangue comprises of minerals associated with the ore. Gangue minerals. Okay, they are extracted profitably because they are unused minerals. Not unused minerals, they are extra minerals which come out during the process. Example, this commonly are silicates, carbonate, fluorides and sulfides. Next is tenor. What is tenor now? It is a metal content of ore. Tenor will be a new word for you. Gangue and ore you will be heard. Tenor will be a new word. Okay, it is generally expressed in percentage, and in case of precious metals, okay, it is expressed in ppm, parts per million. Tenor depends on the price of the metal. Okay, precious metals like what? Gold, silver. Okay, not diamond, gold, silver. Okay, higher the price of the metal, the lower is the metallic content, and vice versa. Higher the price, lower the metal content. Okay, lower the price, higher the metallic content. Okay, okay, next. Now this is nothing much I found as per my this entire what table is given, the entire thing I'm going to learn in the chapter basically. Okay, so let's move on to the next side. Mineral deposits in India. First of all, come to ore minerals. Now ore minerals, they have given how many iron ore minerals, iron ores. There are 2 types. One is what? One is hematite and magnetite. Okay, now hematite. Okay, now I will also give you a PDF which rocks I had studied in my college St. Xavier's. This exact rocks, uska PDF I have removed a photograph and I will give you that PDF also along with the description. Okay, so you can just read this off. Okay, so what to remember, if every mineral you have to remember the chemical composition is very important. Chemical composition is very important to remember. Okay, so in the previous lectures, as we have studied till hematite, and I am recording this video after a very long period of time, I think nearly after 5 months, so sorry for the delay. So let us continue with the remaining part of the video. You might see a change of frame in my in my videograph, so just don't bother that, just focus on the content. Okay, so next part is magnetite. So magnetite, as I told you to remember the chemical composition, Fe3O4, color, luster, streak, form, cleavage, fracture, hardness, Uses you have to remember the uses of each and every mineral over here. So okay, so moving forward, see, you have to like memorize at least not all the names of the geographic distribution, but at least some names which are majorly found. This mineral is majorly found in that region of India. Okay, so these are the two ores of iron. Moving on to the next part is manganese ore. Manganese ore consists of two, that is pyrolusite and silomelane. Pyrolusite has the chemical composition as I told. Remember, the form is very important in each and every one. Botryoidal, reniform, massive, cleavage. Okay, then uses also is very important. Silomelane, the same, the chemical composition, the form, the hardness, uses, and where it occurs, and the geographic distribution same. Next we go to copper ore, chalcopyrite and malachite. I'm going a bit fast because the video has gone a bit little more than supposed to be. Like okay, so chalcopyrite, as you can see the images also, and so I'll give you a PDF of the actual rocks, how it looks. Okay, so these are just photographic images which are taken off from Google maybe. So chemical composition, as I have told you, remaining all contents you have to remember, because this comes as a practical as an identification of the mineral. Okay, so malachite and chalcopyrite. Okay, next we move on to lead ore. There's galena, and there's only galena. Okay, galena. Next we move on to zinc ore, that is sapphirite. Okay, zinc ore, just one, sapphirite. Aluminium ore, bauxite. Okay, as I've told you, just remember everything what I have told you at the start. That is your chemical composition, color, luster, streak, cleavage, fracture, hardness, uses, occurrence, and where the geographic conditions for most of the minerals. Okay, radioactive minerals, you have monazite. The chemical composition is not properly given over here. It has many contents of these metals. Okay, so you can just remember many two metals and PO4, SiO4. Okay, the occurrence, everything. Okay, next we come to industrial minerals. Okay, so before moving to industrial minerals, I just want to give you a quick glimpse of what had come in 2022's papers. I've already told you in the previous chapters. So in the 2022 paper, chalcopyrite had come for 3 marks. Okay, chalcopyrite had come for 3 marks. Okay, for 3 marks. The physical properties of chalcopyrite, so you got to remember everything of this. Okay. Okay, the next which had come in 2022 was industrial minerals. In fact, industrial minerals, this part had come for 3 marks in 2022's paper. Okay, this entire paragraph. Okay, so write a short note on industrial minerals for 3 marks. Okay, then I'll give, as I've told you, I'll give you some important markings as I've given previously. So you gotta mark this thing, the 4 varieties of coal. Then you come down, the transition from peat to anthracite. This is the reason for the transition. Okay, and the best variety of coal is anthracite. Okay, then geographical distribution of industrial minerals in India. Then you come down. Then petroleum, you have, yes, these are the important gases in petroleum. Okay, I am running a bit because I'm so sorry, because this video has gone way beyond the reach. Okay, it's gone more than 1 hour. I know that, though the previous one was the same. Then Petroleum is extracted from earth and known as crude oil. There's just some markings, okay? These are the general geographic distribution. Unconventional sources is coal bed methane, okay, and India is the 5th largest proven coal reserve in the world. Then you come to shale gas. Just gotta read something about this, nothing much. Come to cement industry directly. The first mineral you start with gypsum. Okay, gypsum. Okay, also called as fibrous satin spar. Fibrous satin spar. As I'm saying something, gotta write it. Okay. Okay, then you come down. You have the second cement mineral, that is your limestone. Okay, limestone, not much given about limestone, but the composition of each element is given, which includes in limestone. Distribution in India. Okay, come to next, which is the abrasive industry. We have two types: natural abrasives and artificial abrasives. Got to remember the examples as well. The diamond, corundum, quartz, garnet. Okay, then they have given the example, the distribution of diamond, everything, the chemical composition, everything. Okay, so got to remember this, as this had come in 2022 for 3 marks. Write a short note on the abrasive industry. So they got you any one mineral. So it come for 3 marks. Then second one is corundum. Okay, same part again. Then quartz. You come down, nothing much about this. You come down. Okay, nothing much. Crystalline silica. Okay, just gotta read about it. Okay, then you have garnet. Garnet is one of the most precious looking mineral. Okay, come down. Okay, next you move on. Okay, so this is all about your first. We finished with 2 industries over here. That is your cement industry, gypsum and limestone. Abrasive is diamond, corundum, and you have quartz, you have granite. Okay, next we move on to ceramic industry. Okay, so we move to our next industry, that is our ceramic industry. Okay, ceramic industry, our first mineral is kaolin. So a question had come, a small 1 mark question. What are the minerals included in ceramic industry? So minerals include. Okay, so ceramic industry, kaolin, as I've told you, 1 mark for this word only to write. Okay, next, come down. Okay, this is, I feel, a possible question can come for 2023, 24 or 24, 25, whatever you call. Sorry, 23, 24. Sorry. So feldspar, possible. I'm not saying 100%. Okay, so I've marked whatever is needed. Okay, just gotta read this thoroughly. Actually, these are the also gemstones. Okay, so these are the forms of that chemical composition. Okay, alkali feldspars and calc-alkali feldspars. Okay, so orthoclase and microcline. Okay, then they're given the description about orthoclase. Okay, then under for alkali feldspar, these are the 2 examples, orthoclase and microcline. But for calc-alkali, you have these examples, that is plagioclase and labradorite. Okay, the picture is given, you can see. Okay, so another transition over here present. The 2 boundary minerals, albite and arthurite, are end members. So you got to read this paragraph, and you can see that albite can change to anorthite and anorthite can change to albite. Okay, I have a little bit no idea about this, but just know this transition. Okay, physical properties. Okay, use of ceramic. Yes, this is an important part. It is used in the construction industry. Okay, they are used as insulators. Okay, this semiconductors, magnets, use of ceramic in pollution emission. Okay, so that's it, nothing much. You come down, you come to the next industry, that is your refractive industry. Okay, so this is another question which had come. Write the from here, from refractive industry, three categories you have. First of all is acidic, basic and neutral. You have raw materials, refractive industry is fire clay, kyanite, bauxite and zircon. They had asked a 3-mark question, believe me, a 3-mark question in 2022. Write the chemical composition of the raw materials used in the refractive industry. The chemical composition of kyanite, bauxite and zircon. Okay, so the chemical composition of these three minerals, kyanite is Al2SiO5, Al2SiO5. Then of bauxite is the same thing, Al2O3.2H2O, hydrated form. Zircon is ZrSiO4. Okay, there is mostly silica in this. Okay, then the first one is kyanite. You see, they are mentioned as I told you the same thing. For bauxite, we refer the original one, the previous one which I have showed you, zircon. Okay. Next, we move on to the medicinal industry. Medicinal industry for some medicinal minerals. Okay, so important marking over here is branch of Ayurveda pharmacology in Rasha Shastra. Okay, Rasha Shastra. Okay, so what is an important, some of the important minerals of the Maharasas. So this part, mica, the, what is it, the Ayurvedic name you can say, Abrakha, chalcopyrite, maxica, pyrite, vimala, and malachite is sasyaka. Not that necessary to know. Okay, some of the important minerals in Uparasas. This was Maharasas, okay, and Uparasas is sulfur and hematite. Okay, Ganadhaka and Gairika. And in Sadharana Rasas, Cinnabar. Okay, sorry, I'm a little bit ignorant of the language. Maharasas. So, first is mica, chalcopyrite, pyrite, and malachite. Mica, description of mica. Okay, so having a gut feeling that this can come in the current exam right now. These 4 names, remember these thing. Abraka separates into packed layers, contact of fire. Hissing out sound when heated, naga. Frog jumps on heating, called as manduka. And which does not change on heating is vajra. Okay, remember this vajra, manduka, naga and pinaka. Next we come is muscovite. This is a question MCQ had come 2022 for one MCQ. Okay, MCQ. Okay, this question had come for 1 mark. Yeah, Shweta abraka. This thing in Ayurveda, dash is termed as muscovite. Then biotite, you gotta remember this also. Next, physical properties of mica. Okay, uses you gotta remember. Second is your uparasas, which comes as sulfur and hematite. Okay, hematite is not given, okay, but you gotta know it's sulfur and hematite. Okay, then is Sadharanarasas, Cinnabar. Okay, then is mineral rock industries. Then you come down, just a brief discussion about everything and then the summary. Okay, and then we move to the exercise part. Okay, so our exercise part comes Tenor is an ore of dash. Metal content B of B. Metal content of an ore. Iron. This is the identify the iron ores are minerals of correct one. So magnetite and hematite. The third is the C option. You gotta see it and mark it. Okay, I'm just giving you the answers directly. You can read it in the chapter. In fact, I've explained it. Okay. Okay, this is the P option. Next is question number 2. What is an ore mineral? At the start we did it. 2. This is also is done. Write the chemical composition of malachite. Malachite also is given CO2, CO2, CO3, OH2. What is the radioactive mineral? That is also discussed. Okay, so that's it for this chapter. I explained it in a very short way. I did not explain it in fact. Actually, it's self-explanatory. Even if you just read it up, and I've given the important markings. So thank you for responding and listening to these videos. Okay, so all the best for your upcoming board exams in the next month, and thank you for watching. Subscribe for the next notification. Thank you.